Hi everyone, welcome to AMC8 Summer Practice Quiz 4. Let's get started. Question number 1. If x over 2 plus x over 3 plus x over 6 equals 100, what is x? For this question, it's just simple algebra. For example, for x over 2, we can simplify it into x times 1/2. We can also do this to x over 3 and x over 6. And the whole equation will be simplified into x times 1/2 plus 1/3 plus 1/6 equals 100. And this whole part here will just be equal to 1, which gives us the equation of x equals 100. And that will give us the answer. Question number 2. The numbers 18, p, 13, q, 15, r, 7 have a mean of 11. The mean of p, q, and r is, so we have 7 numbers here, and which have a mean of 11. Mean is the same meaning as average. Therefore, the total will be 7 times 11, which gives us 77. And we know 4 of the 7 numbers. So therefore, we could minus the 4 number from 77. So 77 minus 18 minus 13 minus 15 minus 7. This will give us the number of 24. Therefore, 24 is the sum of the 3 unknown numbers, which is p, q, and r. So the average of the 3 numbers would then be 24 divided by 3, which equals 8. And that will give us the answer. Now let's move on to question number 3. It's a question from the Hope Cup math competition. So below is part of the so-called Pascal triangle, or in Chinese, 阳辉三角. Find the sum of all numbers. So for this question, we just need to find the patterns of the sum of each row. So for the first row, the sum is 1. Second row, 1 plus 1 equals 2. And third row, 1 plus 2 plus 1, that will be 4. And the fourth row, 1 plus 3 plus 3 plus 1, that's 8. The next line is 1 plus 4 plus 6 plus 4 plus 1, that will be 16. And now we can see a pattern that each line is the former line multiplied by 2. So the next line will be 16 multiplied by 2, that will be 32. And the final line is 32 times 2, that will be 64. So we need to calculate 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. So we can use the geometric series formula, but for this question, we can use another interesting way. So what I will do is I will add 1 to the beginning to the whole equation, and I will minus 1 at the end. Therefore, it does not change the total value. But by adding 1 to the beginning, we can see when we do the calculation, we get 1 plus 1 first. We do 1 plus 1 first, and we get 2. And next step, we can do 2 plus 2. And that will give us 4. And 4 plus 4 will give us 8. 8 plus 8 will give us 16. 16 plus 16 will give 32. 32 plus 32, 64. 64 plus 64, that's 128. And we need to minus 1 to 128. So the final answer will be 128 minus 1. That will equal to 127, which is the correct answer. Question number 4. In the diagram, 2 equal armed balances are shown. How many squares would it take to balance one circle? So, looking at the picture, we know that one triangle will balance out 2 squares and 1 circle. So, in the first picture, we have 3 triangles on the left side, which equals to, if one triangle equals to 2 square and 1 circle, 3 triangle will just equals to 6 square and 3 circles. And we can see on the right side, we have 5 circles. So 3 of the circles canceled out, which will give us 6 squares. It's the same weight as 2 circles. So 1 circle would then be 3 squares, and that will give us the answer. Question number 5. On a cube, 2 points are said to be diametrically opposite if the line containing the 2 points also contains the center of the cube. The diagram below shows a pattern which could be folded into a cube. Which point would be diametrically opposite to point P? For this question, we need to use imagination of 3D objects. So imagine if we fold this patterns to a cube. Let's say, let's draw a cube here first. So here we have a cube. Let's put the bottom side on the right side of the cube. And the number here will just be R, S, T, and U. And the upper side will be on the left side of the cube. So using the imagination of 3D, we can see that Q will be this position, this point right here, and P will be here. Just you're flipping the paper to the other side. And we're looking at the opposite point of P, diametrically opposite point of P. And this would then be S. Because looking at the center square of each side, P is at the left lower left corner. And on the other side, S is on the upper right corner. Therefore, that will be the diametrically opposite point, and it will give you the answer S. Question number 6. Alice went to Walmart to buy school supplies. She first spent 1/3 of her money to buy pencils, then 1/4 of the remaining money to buy erasers, and 1/2 of the remaining money to buy paper. If she had $6 left, how much money did she have at the beginning? So we first look at the money left after she bought the pencils. So she spent 1/3 and she will have 2/3 left, right? So 1 minus 1/3. Then 1/4 of the remaining money to buy erasers. So with 2/3 of the big original money, he used 1/4 of them. So she will have 1 minus 1/4, which is 3/4 left. And with this money, he used 1/2 of them to buy paper. So he will also have 1 minus 1/2, and that's 1/2 left. and that will equals to $6 if we times the total money to the beginning. So simplify the equation. T times 2/3 times 3/4 times 1/2 is $6. This would give us 1/4 of T is $6, and T, which is the total money she has at the beginning, is $24, which will give it an answer of 24. Question number 7. In the triangle ABC, line CD and line BE are heights on AB and AC respectively. CD and BE intersect at F. If angle A equals 55 degrees, what is angle BFC? So knowing that angle A is 55, by looking at the right triangle A, B, and E, we can get number DBF is 90 minus 55, which is 25 degrees. And then by looking at a small triangle DBF, we know that the angle DFB equals 55, which is also 90 minus 25, right? We need to get the angle BFC, right? So BFC and DFB form a line which has the angle 180 degree. Then BFC will equal to 180 minus 55, which will give us 125 degree. Mr. A owns a home worth $10,000. He sells it to Mr. B at a 10% profit based on the worth of the house. Mr. B sells the house back to Mr. A at a 10% loss. Then what happened? So there's in total 2 transactions in this problem. So the first one is A sold it to Mr. B with 10% profit, which means that B need to pay $10,000 plus the profit, $10,000 times 10%, and that will equal to $11,000. And for the first transactions, A earns $1,000, right? And for the second transaction, A paid the house back, but B has a 10% loss. So how much did A pay? A actually paid $11,000 minus the loss, which is $11,000 times 10%, which will give us 11,000 minus 1,100, and that will be 9,900. So A at last have a house worth $10,000, and he paid 9,900 to get it back, right? Which he earns $100 from the second transaction, and plus the first transaction, which he make $1,000, he make $1,100 in total, and that will give us answer B. Question number 9. In the first 103 numbers of the Fibonacci sequence, 1, 1, 2, 3, 5, 8, and goes on, how many are divisible by 5? The question is for you to simply find the patterns. So if one number needs to be divisible by 5, we're okay looking at the last digit. If the last digit is 5 or is 0, then it can be divisible by 5, right? So by only looking at the last digit, we try to write the sequence down and try to find the patterns. So 1, 1, 2, 3, 5, 8. Here I have 5 is divisible by 5. And if we do 8 plus 5, we can get the next number, 13. But we're only looking at the last digit. So it's a 3. And 3 plus 8, 11. So that gives us the 1. The last digit is 1. 1 plus 3, 4. 1 plus 4, 5. And here we have another 5. 4 plus 5, 9. 9 plus 5, 14. So that gives us 4. 9 plus 4, 13. So it's a 3. 4 plus 3, 7. 7 plus 3, 10. So that gives us 0. And 0 is also divisible by 5. So with these patterns, we can see that every 5 numbers, we have one number, the 5th one, is divisible by 5. So we have in total 103 numbers. Divided by 5, we get 20, and we have the remainder of 3. So that will give us the correct answer, 20. Question number 10. Randomly roll 2 standard dice. What is the probability that the product of the 2 obtained numbers is divisible by 6? So we're trying to calculate the probability. And the formula for calculating probability is that P equals number of favorable combinations over number of all possible combinations. So in this case, all combinations is just 6 times 6 because each dice have 6 numbers. So we have 36 combinations in total. And we need to calculate the favorable combinations, which in this case is the combination that the 2 numbers times together is divisible by 6. So there's 2 cases. Case 1 is that one of them is 6 because 6 times any numbers will still be divisible by 6. And that will give us, let's set the first dice to 6. And no matter what number the second dice gives us, the product will still be divisible. So there's 6 combinations if we set the first dice to 6. And if we set the second dice to also 6, that will also give us another 6 combination. But notice that one of the combination is repeated, which is the combination of 6, 6. So we minus 1 from them, and case 1 will have 11 combinations in total. And case 2 is 3 times an even number, because what's the prime factor of 6? It will be 3 and 2. So 3 times any even number will give us a number that is divisible by 6. So we can just list the combinations. So set the first dice to 3. The second dice could be 4. It could be 2. It could be 4, or it could be 6, right? Same if we set the second dice to 3. And here is the total combination for case 2. But also notice that some of the cases are repeated, because 3, 6 is repeated in case 1, and 6, 3 is also repeated in case 1, so we don't need to count them. And case 2 would then have 4 combinations. So the total combinations, favorable combination is 11 plus 4. And all possible combinations in total will be 36. So it's 15 over 36. Simplify it, we get 5 over 12. Let's move on to the next question. Question 11. For how many positive integers n that is no greater than 1000, n squared is divisible by 12. So n smaller or equal to 1000 and n squared is divisible by 12. In order for n squared to be divisible by 12, n needs to be divisible by 2 and 6. 2 and 3. Because 12 have the prime factors 2 and 3. So therefore we can just use a simple big division. So 1000 divide by 6 and we get 1, 6, 6. So therefore the number is 166.
Question number 12. Ria bakes 6 Raspberry Pis, one after another, numbering then 1, 2, 3, 4, 5, 6 in this order. The first one being 1. While she's doing this, her children sometimes run into the kitchen and eat the hottest pie. Which of the following could not be the order in which the pies are eaten? The answer for this question is D. Now let's see why D is impossible. Okay, so if let's say if the 4 is the first one is eaten, then what happens is 1, 2. So okay, so right after the first pie was baken, and then his children eat 4. So this is what happens. 4 is the first one eaten because it's the hottest. And then the next one eaten 5. So what happens is 1, 2, 3. Okay, 4 is gone. And after 5 is baken, then 5 is eaten, it's gone. Okay, and 6, then okay, so 1, 2, 3. Okay, 4 is gone, 5 is gone. Okay, and then it's 6. All right, so 6 is eaten. And then it says, well, after all those things, 3 and 4, 5, they're gone, and go back to 2 is eaten. Well, but we know this is impossible because for this step, 3 is the hottest, right? So that's why it is impossible. Okay. Now, for the others, this is fine, this is fine, this is fine, this is fine. Now, let's pick one of them to demonstrate why it's fine. Let's see, look at this. Why this one is fine? Okay, so why 3, 2, 4, 5, 4, 6, 1, this one is okay. Why this one is okay? All right, you see, the first eaten is 3. So what happens is 1, 2, 3. So right after 3 is baken, pie 3 is baken, so this one is eaten. The next one eaten is 2, right? So that means before the pie 4 was baken, this one is gone, 2 is eaten, right? So that this happens right before pie 4 was baken. And then 5, okay, happens 5 is 1, okay, 2 is gone, 3 is gone, now 4 is baken, and 5 is baken. Okay, so then 5 is eaten, right? Okay, and then it's 4, so it's 2 is gone, 3 is gone, 5 is gone, okay, and then 4 is, okay, so 4 is eaten, right? Because before 6 is baken, 4 is for the remains, that 4 is the hottest one, and the last one is 6, right? So it's okay. So 1, 2, 2, 3, 4, and 5 is gone, and for 6, oh, all right, right after 6 is baken, 6 is gone, and the last one, of course, number 1 is the only remains, right? The remains, then eat this. Okay, so then this one is okay. It satisfies the requirement that the order those pies are eaten is from starts from the hottest, whatever remains on the table, right? Question number 13. Suppose that n is expressed as 3x times 3x, 4y, and z. And here, x and y, x, y, z, for each of them is either 1 or -1. The question is, how many of the following statements are true? First of all, we know that because x is 1 or -1, and this guy is always odd. Right? It's always odd because 3 is odd times odd is odd. This one is always even, and because 4 times something, right? So this one is odd, right? So we know in terms of the parity, right? In terms of parity, n equals odd. Okay, so this is odd plus even. Okay, so this is even, and plus another odd, regardless what it is. And then we know odd plus even plus odd, this one ends up with even. All right, so we know that n is always even. This one is correct. Then n is always odd. This is wrong. Now, let's look at the first statement. Can n ever be 0? No, which is impossible. It's easy to check. This one is impossible. Regardless how you do it, you cannot make n even. All right, so how about this guy? It says n cannot equal to 4. The question is, are we able to make some arrangement so that n equals 4? The answer is yes, because we can do is 3 times 1 plus 4 times -1 plus 5 times 1, which is 8 minus 4, which is 4. So which means n could be 4, and accordingly, this statement is wrong. Okay. All right. As a conclusion, there's only one statement that is correct. N is always even.
Question 14. It is 3:40 p.m. now. After k minutes, the hour hand and minute hand point to opposite direction the first time. Which statement concerning k is true? So we need to calculate what value is k. And let's calculate how many degrees will the hour hand and minute hand move in 1 minute. So the whole clock is 360 degrees, right? And there's 12 hours in total. So each hour, the hour hands move. Each hour it moves 360 divided by 12, which is 30 degrees. And there's 60 minutes in 1 hour. So each minute it will move 0.5 degree per minute. And that's the hour hand. And for minute hand, it move, so it will make a circle in 1 hour, right? So 360 degree in 60 minutes. That will give us 6 degree per minute. And it's 3:40 p.m. now, so we need to calculate the degree between the hour hand and minute hand right now. We can see from the picture that it has 4 hours. 1, 2, 3, 4, plus the small angle right here. And the small angle, because it has already gone 40 minutes past 3, so the hour hand moved 40 times 0.5, which is 20 degrees. And it has another 10 degrees to go. Therefore, the angle right now is 4 times 30 plus 10, which is 130 degrees. And in order for the hour hand and minute hand to be in the opposite direction, we needed to be 180 degrees. So it looks like the dotted line right here. And so we need the degree to be 180. and now it's 130. So we need the minute hand and hour hand angle to increase by 50 degrees. So it's like a chasing game. So 50 degrees divide by the speed difference of minute hand and hour hand, which is 6 degrees minus 0.5 degrees. And that will give us an answer of 9 point something, which is corresponding to solution 4. K is between 9 and 10.
Question number 15. N is the smallest number such that 72 times n is both the square and the cube. What is the remainder when n is divided by 11? First of all, let's remind ourselves when a number is a square and when a number is cube, right? So the characterization. If we have for a square, for a number to be a square means if you look at the, so one way to categorize it, if you look at its prime factorization, all powers of its prime factors are even. So this just means all powers, or we say all exponents. All exponents of its prime factors are even in the prime factorization, right? For example, you can think of, say, for example, 100, right? 100, we know it's 2 square times 5 square. And then you see this is even, this is even, right? Both of them are even. And how about a cube? Cube means all exponents of its prime factors are divisible by 3. Right? For example, if you look at 1,000, right? 1,000 is 2 to the 3 times 5 to the 3, right? So, okay, so 2 and 3, so this 2, okay, so they're just divisible by 3, right? Divisible by 3. Now, so if you have a number, how about it's okay, so how about it's both square and cube? Well, both, if you combine, right, so if it's okay, if I combine both square and the cube, this is equivalent to saying that all exponents of its prime factors, all exponents are divisible by both 2 and 3, so which means are divisible by 6, right? So if that's the case, then it's both the square and the cube. Let's look at our problem. We have 72 times n, that's the prime factorization. 72, which is 9 times 8, so it's 2 cube times 3 to the 2 times n. Now we are looking for the smallest number such that this is both square and the cube. Oh, well, in order to smallest, then we say, okay, if we want to the smallest, then I can, the smallest one I can make is 2 to the 6. Remember, we need to satisfy our requirement. All exponents of prime factors has to be divisible by, have to be divisible by 6. So it's okay. The smallest is 2 to the 6 times 3 to the 6. Okay, then clearly we get n is 2 to the 3 times 3 to the 4, which is 8 times 81, right? 8 times 81 is 648. And now what we are looking for is the remainder when this one divided by 11. That's okay. So let's do this, which is 5, 5, 9, 8. So it's 8, 88. Okay. So we get is 10. All right. So the remainder is 10.
Question 16. A sealed wine bottle consists of 2 cylinders as follows. The depth of wine was 7 at the beginning. If the wine bottle is put upside down, what is the new depth of wine? Note, the volume of a cylinder is pi r squared h, where h is the height and r is the radius of the base. So just to review the formula, pi r squared is the area of the base and times height. It will give us the volume. So let's look at the picture. It contains of the big cylinder at the bottom and the small cylinder at the top. If the water is flipped upside down, I draw a illustration here. You look like this picture right here. But what does not change is the volume of the water. It will keep constant. So let's calculate the volume of the water first. So using the formula pi r squared times h. Here, the water at the beginning is in the big cylinder, which has the radius 4. So times 4 squared, and the water height is 7. So 7. And that will give us 1/12 pi. And if the water is flipped upside, the container is flipped upside down, it will look like this, right? Look at the picture to the left. So it will first fill up the small cylinder and then fill up the big cylinder. So let's calculate if it will fill the whole small cylinder up. So V small, also using the equation formula pi r squared times h. And the small cylinder has a radius of 2, so times 2 squared, and the height of 4. That's 16 pi. And the water will definitely fill up the small cylinder. And they will have 96 pi volume of water left. And we will calculate how much space of the big cylinder will this many water fill up. Let's make an equation here. Pi r squared h equals to 96 pi. And the big cylinder have a radius of 4, so pi times 4 squared h equals 96 pi. And simplify the equation, we get 16h equals 96 pi. Sorry, 16h equals to 96. And h will equal to 6. So it will take up the height of 6 of the big cylinder. Also height of 4 of the small cylinder. And that will give us height of 10. So the answer is number C. Question 17. Use 3 colors, red, green, and yellow, to color the following 5 regions, A, B, C, D, and E. In how many ways can we color them so that each region has only one color and 2 adjacent regions have different colors? So looking at the picture, we can see that A, D, and E are adjacent to each other. A and E are adjacent, so it needs to have different color. D and E are adjacent too, so they need to have different color. A and D are also adjacent, so they need to have different color. That means that A, D, and E should have 3 different colors. For example, if we make A red, E can only be green or yellow. Let's say it's green. And D can only be yellow, right? And if A, D are determined, then B is determined because B is adjacent to A and D. So B can only be green. If B and D are determined, C is also determined. So C can only be red. Therefore, if we determine the color of A, D, and E, the color of all 5 regions are determined. And how many ways are there to color A, D, and E? Because it only need to be different colors. So the total ways will be 3 factorial. That is 6. Why is it 3 factorial? Because let's first determine the color of A, and we have 3 options, red, green, or yellow. So it's 3. And then we determine the color of D, and we can only choose one from the other 2 colors. So that's 2. and E is the left color, so that's 1. So to give us the answer 6, and the solution is then A. Question number 18. A point xy on the coordinate plane is called a lattice point if both x and y are integers. How many lattice points will be contained in the interior of the triangle bounded by the x and y axis and the line 3x minus y equals 6? So let's first convert the form into y equals 3x minus 6. For this question, we simply need to draw out the xy axis and the line, and we can tell by the graph. So x-axis, y-axis, 3x minus 6. So the y-intercept will be 0, negative 6. And the x-intercept is then 2, 0. And the line will be like this. And we check how many lattice points is in the interior of the triangle. So let's draw a line here, a line here. So from the graph, we are sure that this point, 1, negative 1, and this point, 1, negative 2, is in the interior. But we're not sure that if the third point is in the interior or no, because it's kind of to the borderline. And we can check this easily if we plug in x equals y to the line function. So when x equals y, x equals 1, y will be negative 3, right? And the point is 1, negative 3, which is actually on the line, but not in the interior of the triangle. Therefore, only 2 points are in the interior of the triangle, and that will give us the answer 2. Question 19. X, y, and z are 3 real numbers satisfying that x plus y equals 4, xz equals 9. The square of x plus y plus z is 25. What is the sum of all possible values of y? Notice that x, y, z squared equals 25. So there are 2 cases. One is x plus y plus z equals 5. And the other one is x plus y plus z equals negative 5. Don't forget there will be a negative when you solve a square number, okay? So if x plus y plus z is 5, knowing that x plus y is 4, that will give us z equals 1. Knowing that xz equals 9, then it will give us x equals 9. And knowing that x equals 9, z equals 1, we know that y equals negative 5. Because x plus y plus z is 5, right? And we solved the second case too. X plus y plus z equals negative 5. Knowing that x plus y equals 4, we get z equals negative 9. And knowing that xz equals 9, we get x equals -1. And knowing both x and z, we get y equals 5. So the possible values of y are -5 and 5. So -5 plus 5 equals 0. Last question, number 20. ABCD is a square of side length 12. So we get AD is 12, AB is also 12. EFGD is a rectangle with FG equals 16. Therefore, we have FG is 16. E are on AB, C are on FG. What is EF? We need to make a assisting line here. So connect EC. And we look at the area of the triangle EDC. Notice that it is actually half of the area of the square ABCD because it shares the same base and the same height. It shares the base of CD, which is 12, and it shares the height. The height will equals to BC, which is also 12. Because the area of a triangle is 1/2 base times height, right? Therefore, the triangle EDC is half the area of the square ABCD. Notice that it is also half the area of the rectangle EFGD. Same reason for the square, because it shares the same base, 12, no, share the same base of ED, and it share the same height of DG. Therefore, we know that area of ABCD equals to area of EFGD. And what is the area of ABCD? It's a square, right? So it's 12 times 12. And EFGD is a rectangle, so it's one side to the adjacent side. So it is EF times FG. And FG, it gives us a number 16. So EF would then equals to 12 times 12 over 16. Which will give us 9. And that is answer B. And that is the end of quiz 4. Thank you.